In this video, we're going to solve two integrals by the method of integration by parts. The first one, I'm going to use table differential integral method, but if you want to know how we can solve it without this method, with the original way of doing integration by parts, you can watch the previous video. So let's do it this way. In this integral, we have x to the fourth, which is algebraic, and cosine dx, which is trig. Between these two, we pick u, x4, and the rest, which is cosine of x. We usually don't write the x here. Okay, for the first part, which u is, we would take derivative, and this one we would take integrals. We would take derivative as long as we reach to 0. So the derivative of x to the 4 is 4x cubed. Again, if we take derivative, that would be 12x squared. Next derivative will be 24x, and next one will be 24, and we know that the derivative of 24 is 0. So 1, 2, 3, 4, 5 times of derivative. So we're going to take integral 5 times. We know that the integral of cosine is sine of x, and integral of sine of x is negative cosine of x. And integral of negative cosine is negative sine of x. And whenever you think of having negative or none, just take derivative of this one. So is derivative of negative sine of x the same as negative cosine of x? The answer is yes. Is the derivative of negative cosine of x sine of x? The answer is yes. So we're doing good. And integral of negative sine of x is cosine of x, and integral of cosine of x is sine of x. Now we're going to multiply them like this. These are multiplied together, and we start with positive, negative, positive, negative, and positive. So the only thing that is left is writing the answer as you see here. So the integral of x to the fourth cosine of x dx would have the answer of x to the fourth sine of x. This one will be positive because we have two negatives, so plus 4x cubed cosine of x. The next one is a negative 12x squared sine of x minus 24 cosine of x plus 24 sine of x. And as usual, we would put plus c at the end. Next question is evaluating the definite integral from 1 to 4 square root of x ln of x. So in here, we have square root of x, which is algebraic, and we have ln of x, which is log function. So between these two, we would like to pick ln of x as u, and the rest will be dv, the rest including dx. You may think of using the table here, but if you do so, let's think of it. If we pick u as ln of x and this one as, okay, this is not correct. This is square root of x. So take derivative. ln of x will have the derivative of 1 over x, and next one will be negative 1 over x cubed, x squared, and it goes on and goes on as different fractions with different powers, and it never reaches 0. So this doesn't work here. We have to use the derivative and differentiation here as the basic way, the original way of doing integration by parts. So u is ln of x, dv is the square root of x dx. We're going to take derivative of both sides here. That would be du equals 1 over x dx. And this one, since square root of x is the same as x to the power 1 over 2 dx, when we take integral, we're going to have x to the power 1 over 2 plus 1, which is 3 over 2 over 3 over 2. And we can simplify this as 2 over 3 x to the power 3 over 2. Now, following the formula, which says uv minus the integral of v du, u is ln of x times v, which is 2 over 3 x to the power 3 over 2 minus, this will be from 1 to 4. The integral from 1 to 4 of 2 over 3 x to the power 3 over 2 dx. And we can simplify this as, okay, we wrote v here, and du is 1 over x times dx. After simplification, we would have 2 over 3 x to the power 3 over 2 ln of x from 1 to 4 minus the integral of 1 to 4. We can bring out the coefficient here, the constant, and it is x to the power 3 over 2 over x, which means x to the power 1. So we would write it as x to the power 3 over 2 minus 1, which is x to the power 1 over 2. So this is why we would write x to the power 1 over 2 here, dx. Now, we have 2 over 3 x to the power 3 over 2 ln of x for the first part, or you can plug in those numbers here, or you can keep it for the next step. So negative 2 over 3 as we have here. Now, what is the integral of x to the power 1 over 2? That is 2 over 3 x to the power 3 over 2 as we did here from 1 to 4. So we can plug in numbers and we would have 2 over 3. Okay, let's say how we get this one. I would like to combine them. So 2 over 3 x to the power 3 over 2 ln of x minus 4 over 9 x to the power 3 over 2, all from 1 to 4. So if you would like to plug in 4, you would have 2 over 3 times x to the power 3 over 2. X is 4 here. So we have 4 to the power 3 over 2. It means that you are going to write 4 and square root, which means 4 to the power 1 over 2, all to the power 3, because we know that this is 4 to the power 1 over 2, all to the power 3. And square root of 4 is 2, so 2 to the power 3 is 8. Let's keep it here. So we're going to have times 8 ln of 4 minus 4 over 9 with the same reason 8 here. These are all when you plug in 4. Minus, now it is time to plug in 1 here. So if you plug in 1, we would have ln of 1 for the first part, which is 0. So 0 for the first part. Minus, if you plug in 1, you get 4 over 9 here. And all together, we would have 16 over 3 ln of 4 minus 28 over 9. Or you can use calculator, but this is fine if you keep it this way.